I'm not going to hold you for all that information. You won't have to memorize that, as well as a chart over here showing you the names of some of these varieties that are direct producers put out by the different breeders. But over here on this chart on the right-hand side, why Salzburg brought up the fact that when I gave you 1616 and 1613, I mentioned that they were a hybrid of Vitis solanus viriparia. Well, actually, 1613 is not, it's like he said, it's Vitis solanus crossed with the variety Othello. And the Othello variety is really, you look into it further, it's called, you don't have to copy this, I'm just giving you information. It's Arnold's hybrid, or a Canadian Hamburg. And it's actually a Labrusca vinifera hybrid. So in other words, it goes back, it's more than a single hybrid in itself. In other words, that's just information I wanted to clear up on that chart I had over there with regards to the rootstock 1613. Starting in today, we're going to start first with cuttings, and let us define a cutting as a segment or part of a vine that is used for the production of another vine. That is what a cutting is. So in other words, it can either be a dormant cutting or it can be a green cutting. And the smallest cutting that you can possibly use would be a one-bud cutting. And I think I've told you about that in the lab, where they're involved in rapid propagation. They're getting greedy. They're trying to make everything stretch as far as they can, so they're going down to one-bud cuttings. If they really want to get more technical, they could even take a bud itself. Just cut off a bud. You can actually get roots on that, and that thing would grow into a shoot. But for practical purposes, why, most of your nurseries are using a little one-bud cutting like this, and they put it in the vertical position. It roots down here and forms your shoot. But you can go as far as that. Now, you can't say a leaf would be a cutting. You could take a grape leaf, and you could put that in the under mist. You could get roots on it, but you wouldn't get anything growing. So in other words, you couldn't call this the smallest part for reproduction because you wouldn't get a shoot out of it. But it will root on you, and it'll sit there for a long time doing nothing. But your smallest cutting is considered a one-bud cutting, and you can get them as long as you want, as long as the grower wants to plant it in the ground up to 3 feet if he wants to. You want to remember, though, that the vines that you get from cuttings are not a new individual. They're a reproduction of the original individual from which that cutting was made. There's been no changes. In other words, from a heredity standpoint, everything is the same. So in other words, if you look back onto that original Thompson seedless that came up here to Yuba City back in 1872, and from all the millions of vines that have been planted down in Fresno of Thompson seedless, there's really been no changes in the variety because they've been propagated by cuttings. So they essentially remain the same. All the genetic characters are exactly as they were in that original vine. Now, wherever he got that vine, it came from someplace back in Timbuktu, probably someplace over in Asia Minor, and it was exactly like the ones that came from over there. These characters are constant, and the characters that we consider pretty much constant are your color of your fruit. In other words, if the variety is white, it's going to stay white. If it's black, it's going to stay black. The shape of your berry, the size and shape of your cluster, your flavor, your vigor. All these characters are within reason constant. They don't change. They may vary a little from one locality to another. But in other words, if the vine is vigorous, it's going to be vigorous back in South Africa just as well as it's vigorous here. If it's going to have a certain shape of a berry to it, like a tokay has a certain shape, you can recognize that shape here in Lodi. You can recognize the same shape over in Europe. So in other words, these characters are constant. Now, with all this harangue I've been giving you, now I got to start in backtracking. But we do get some changes occurring. And we get types of changes that are genetic changes. They are inherited. So what do we call them? Well, when those things occur, we call them mutations. And they are genetic. In other words, they're passed down from one vine to the next once this change occurs. It's a permanent change. All right, let's take some examples of these genetic changes. They don't occur very frequently in nature, maybe one in 15,000, one in 20,000, or even less. But once they do occur, then this occurrence will maintain itself right on down through the propagation of the plant. Let's consider, first of all, color. And in the nature, in the wild, black is considered dominant over white. So we do have these occurring. Now, a good example of this is Pinot Noir. And we have had colors changes occurring, and we've found out that we also have one that comes out as sort of green in color. We call that Pinot Gris. And we've also had other colors come out, and we have another one that mutates down to the white form, and we call it Pinot Blanc. That's an easy one. Or you all know the variety Grenache. And when you look up in the ampelographies, they always say Grenache Noir. Well, I wonder why. Because you can also find a Grenache Gris. It's a green form. We don't see much of it. And there is such a one that is known as a Grenache Blanc. It's a white form. You've also heard of the variety Gray Riesling. It's a pretty good Riesling type. It's not a true Riesling. Well, where did it come from? It came from that one that we call Trousseau, which is a black type of a Gray Riesling. The vines look exactly the same. They have the same vigor. Production is all the same. Only that's the black cousin to Gray Riesling. We have also a minor one. I'll tell you about it. It's a little segmented type. It's Thompson, which is known as Sultan Nina. And that goes to a Sultan Nina marble. It's a marbleized Thompson. In other words, it has little white and yellow sectors around the berry. It's a very beautiful thing. It's only a novelty, but it is one of these genetic mutations. So we have several of these mutations here for color. Now, color is one of them. How about time of maturity? Another type of a genetic mutation. And I told you that we had cardinal, and they found back in Arizona, I think it was Arizona, no, it wasn't Arizona, but Thornburg found this one that he called Robin, which was about 10 days, a week to 10 days ahead of cardinal. And we also have one, you might say it involves a change in the shape of the berry, but it's one of these ones that Dr. Olmo developed under X-rays. He didn't like the Perlet variety because it was too tight a cluster, so he thought perhaps by X-raying it, he could loosen up the cluster. So he X-rayed his Perlet, and he selected something out that he calls loose Perlet. And it has a lot of shot berries in it. Well, it hasn't been too successful. You seldom hear of it, but it's a form of a Perlet that was loosened up on the cluster. Okay, and then in nature, we have one that involves the size, not only of the vine, involves the size of the berries, involves the size of the clusters, and it's a mutation that occurs most frequently in nature, and it goes to a bull a type of a bull vine, or it's an autotetraploid. Autotetraploid. This is what it's really a genetic mutation. It's a doubling of the chromosomes. In other words, we have 38 chromosomes in most vines, and this goes to 76. And what it does is your leaves are much thicker. They're much larger. It looks almost like a giant size of the variety itself. The fruit tends to be a little more round. The berries are much larger. The seeds are they're double in volume, not in linear dimensions. But everything else essentially stays the same. They're not quite as vigorous as your ordinary diploid vines. But this is probably one of the most frequent mutations that occurs in nature, and your fruitfulness is greatly decreased in most tetraploids. This is the bad part about it. There's been only one case where a tetraploid has been used commercially, and that's this one that Dr. Olmo developed by breeding, and it's the one called, it was Niagara crossed with camel, and both of these were tetraploids to begin with, and he got this Niabel, and that is a tetraploid, but it didn't occur by mutation. Actually, he actually made the cross, and this is the only commercial case I know where a tetraploid has been used in commercial operation. The only thing good about it is the berries are really big king-sized berries. And that's the nice part about a tetraploid. You do get large sizes. In addition to these genetic changes, we also have another type of a change, and it's an environmental change.
Did you say the Niabel was 4?
Niabel is tetraploid, it's 4X, yes. But it's not a result of, say, a diploid Niagara crossed with a diploid camel. This was done at the tetraploid stage. We have a collection of tetraploids out in our variety collection, and the actual crosses were made at the tetraploid level.
Dr. Allen, when you first notice these changes in a plant that's grown from a cutting, where do they first occur? Is it just one berry that's different from the other?
No, it occurs generally as a shoot off of the vine someplace, if you can recognize it. It occurs as a bud down at the base, but this bud goes into a shoot, and it first occurs as a shoot. Unless that particular bud happened to be used, say, to bud onto a rootstock where you get the whole vine as such, no. You'll find it as a bud, which will give you a cane. If you can recognize it, then you're doing fine. Now, your tetraploids that occur in nature occur the same way. They generally occur as a shoot or something, but they're much more vigorous than the ordinary diploids. So when the leaves are off the vines and you're going out making cuttings, then you end up, say, making a greater proportion of tetraploid cuttings than you do off of the normal vine, and then this is the way you get this started as a whole plant.
Didn't you say they were decreased?
No, they're increased in vigor, decrease in fertility. They do not produce as much.
But didn't you say the vine has slightly decreased vigor?
No, they're more vigorous.
You said it, but
If I said it, let's change it right now. Cross that off, they are more vigorous, because you'll see a tetraploid vine out in the field and it'll be almost twice the size. It doesn't have the crop on it. There's no load, so the thing really goes hog wild. So unless you know about these vines occurring in a vineyard, you go out in the wintertime when there's no leaves on it, and you see this big husky thing, oh, that's the thing for me, and you make cuttings off it, then you end up with a whole vineyard that won't produce anything. Because we often call these bull vines, meaning they don't have much in the way of fruit.
Meaning they're very vigorous.
Okay. Now we have environmental changes that do can affect the color of our fruit and whatnot. I'll give you a few examples of environmental changes. One could be, say, where you plant a variety in a rich soil that has plenty of water, this vine will, say, tend to have more vigor than the vine itself. It'll probably have poorer color. If it's a table variety, it'll be late in maturity. So this is an example of environmental change. Or conversely, the opposite. If you happen to have a vine planted in a poor soil that's dry, it's going to be weaker in growth, but the fruit will mature earlier. It'll be earlier in maturity, and it'll probably have better color. A good example of this is where you're growing emperor in the Visalia area, where you have a shallow soil. The minute you start withholding the water on those vines, what do? They start maturing right away. They stop their growth, start maturing. Where you have deep soils, those vines will keep on growing later in the season, so your coloring will be later in coming in. So in other words, you can manipulate some of these changes by these environmental conditions. Even the locality. In Italy, you take Muscat of Alexandria. Every little district you go into, it's going to have a different name. So that's an environmental change. You go over to this little Torino area, it's going to be called one name. You go over here to Piedmont, it's going to be called another name. You go down to the Bari region, you're going to have another name for it. So in other words, you can have a locality difference. Probably the most effective in the environmental changes, however, is your temperature effects. Eric?
About the name, changing the name changes the vine or something?
Oh, no, it doesn't change the vine. It has a different common name. No, in other words, a lot of people call Johannesburg Riesling the variety in Germany because it comes from that Schloss Johannesburg. We don't call it that. We really call it white Riesling. But over there in that particular area, it's so famous there, it's known as Johannesburger Riesling. Your temperature changes, probably the best example of that is what you find in Lodi. Now, within a 6-mile radius of Lodi, your Tokay reaches a peak of color. It's a bright red. Because you have these cool nights occurring in the summertime. As soon as the sun goes down, the temperature drops very quickly, and this variety likes a cool night. You go down to Delano or Fresno, where it's hot, your Tokay is poor. It doesn't develop a bright red color. It can be pink even, so it's very poor. Or you come to Davis here, and you plant the Tokay, and it's purplish red. The environmental conditions are not right for the development of that bright red color. So, in other words, your environment does really affect a lot of especially your red table fruit. Emperor is beautiful in Delano, in Fresno area. You bring it up here, and it's purplish red. There's too much cool temperature for it. You bring it to Oakville, further north in Napa Valley, and it's even darker yet. So this is a good example of your changes. Okay, now let's go one step further now. Let's go into our cuttings. We have our one-bud cuttings, our standard length cuttings, which I've already told you in lab. The length depends upon the type of soil where you're going to grow it, how deep it is. But what is our best cutting, generally considered? Well, if we look over here at this table, we ran this a year ago because we knew that the basal cutting was considered to be the best type of a cutting. But there was no evidence in the literature as to why. So we ran this a year ago to find out. We took 2 types of basal cuttings and a mallet cutting. Now, one basal was a 16-incher, the other was a 24. The mallet cutting, which is a special type of a basal cutting, I think I've showed that to you already. You have a little bit of 2-year-old wood right here. This is 2-year-old. And the rest of your base is very similar to your basal. And then the cuttings, as you make them out in the field, you make basal and you make 2. The second cutting, the third cutting right on out is known as field run. So we compared the rooting of them. And here's your percent take, and it goes anywhere from 96 down to 82, and for all practical purposes, from a statistical analysis, there was no difference in the percentage of take there. This tended to be a little lower. There is some evidence that the take wasn't quite as good. If you have a big hunk of 2-year-old wood there, your rooting generally is not quite as good where you have a big hunk on it. And this might have affected the take on that. But when we go to the weight, you take a look at the weight here. Your mallet cutting was your heaviest. Your basal cuttings were your next heaviest, and your field run were the lightest cuttings. And this is where the big change occurs as far as a mallet cutting being the best. It's the heaviest cutting overall.
Dr. Allen, does this weight include the mallet itself? Or did it?
Yes. In other words, this is the full weight of everything.
So the mallet was weighed in there too?
The mallet, everything is weighed. In other words, you don't separate that. You just include that in.
That's just the weight of the cutting before you plant it?
Now, this is the weight of the rooting.
After it's done.
Actually, I took the weight of the cutting as well, and subtracted the weight of the cutting to come out here and to see which one developed the most. But that's beside the point. Actually, the greatest increase in weight were your basal cuttings, and this was the poorest overall increase in weight. But you've got to recognize the fact that these were the heaviest rootings to be the end result. So really, if you want heaviest rootings, your mallets are the best. But they're not always easy to obtain. It takes a special type extra work in order to get them, so sometimes it isn't worth it.
What do you mean by heaviest rooting? Does that mean the most roots?
They have the biggest roots, the biggest top, everything. In other words, it's a bigger rooting all around. The overall size of the rooting is larger, it's heavier. It has a very heavy root system.
Don't you normally clip it back to a 1-inch length anyhow before you...
Oh, you mean the roots?
Yeah.
Well, you clip them back to accommodate the size of the hole you're going to dig. But in other words, here's, you're starting out with the standard rooting here, and the mallet might be what you call a king-size rooting. It's a little larger in size. Now, if you're going to cut it back, it doesn't make that much difference for all practical purposes. Really, there's not that much difference between a basal over a mallet. Because you can adjust the size of the rooting to fit the size of your hole, and you'll have to cut it back anyway, as well as cut off most of the top. Oh, pardon? Field run, that's a Duke's mixture. In other words, you have basal cuttings, you have your second cuttings, you have your third cuttings, if you can make that many. It's everything combined. Rather than just selecting out certain groups of cuttings, we threw in everything as you would as cuttings come in.
Which one had the greatest percent increase in weight?
The mallet. The mallet cuttings were the heaviest cuttings.
No, percent increase.
Oh, the overall, when you subtract the initial weight, your basal cuttings, these two right here were the greatest. They increased the greatest, this increased the second, this was the last. As overall increase. Percent increase, yes.
Well, do you think there were many third cuttings in this, or just basal in the next?
There was probably mostly a basal and the second. But there's a much higher degree of variability in your field run cuttings. Now, if we're going to make cuttings, how would we select our cuttings? Well, probably the most important thing when you're making cuttings, you want to make sure it's true to variety. So if you're out there making cuttings of Cabernet Sauvignon, let's not be getting any of these niggers in the woodpile. Make sure you've gone out and inspected a vineyard. If there's any mixes in there, if you've got some other variety, mark them some way so when you make the cuttings in the fall and you can't tell what it is, that you avoid those. So that's the most important thing when you're making cuttings, is be sure they're true to variety. Now, the next thing is to select cuttings. Second thing is make sure they're free from virus diseases. If you're out in one of these certified blocks that's been inspected by the state people, there's nothing to worry about, or there should be nothing to worry about. At least you won't have to be concerned with virus diseases. If you are going into a vineyard that the virus condition is unknown, then you better check your vines the year before while they are growing. And you better know what some of these virus disease symptoms look like, so any vines that look off type, mark them. Mark them especially in the late spring when they'll show one type of disease, especially a mottling, and then go through and mark them, most important, just before you harvest, to see the type of a crop it has, whether it has a normal crop or whether it has a poor crop. There are certain varieties, and a good example of one is Kerrigan or Valdepena, both of those varieties. They have a virus disease known as unfruitfulness in them, unfruitful condition. And you can tell them out in the field by the fact that they're almost like these tetraploid vines. They're super king sizes because there's no crop to hold them back. This is a yellow vein is the name of the virus that you find in Kerrigan and in Valdepena. They have plenty of flowers, and then all the flowers shell off right after bloom, so there's nothing to hold them back, and they get very large. And that they resemble almost a tetraploid in size. Of course, they're a normal vine as far as the leaf characters go and everything else. But they don't produce fruit. That's a minor detail. So if you want a good vineyard in the future, you want to avoid vines that carry a virus disease, as well as avoid these tetraploid vines, which are bull vines. You can pick these out during the growing season. And it is possible for even tetraploids to occur, say, in clean stock. That's not out of the realm. It could occur. So if you can recognize these conditions and avoid those, then you can avoid a lot of headaches for the future of the vineyard. A third criterion for selection of good cuttings, if you have the chance where there's plenty of wood available, then use your basal cuttings. Those are the ones that will root the best. They'll give you the nicest rooting at the end of the year. Use basal cuttings. If there's a shortage of wood supply, you don't have any choice, then you've got to go to the second cutting and third cutting. And when you do make your cuttings, don't choose these big horses like I showed you in the lab. Choose your medium-sized cuttings, and they will generally vary between, say, 3/8 of an inch up to 5/8 of an inch in diameter at your base. Fifth good criterion to follow is choose cuttings that have a moderate or medium internode length. Don't choose the great big long internodes. Choose a moderate internode length that generally shows a satisfactory growth. And then you'll have cuttings that grow very vigorous. Towards the end, the internode length may slow down, but the wood will not ripen. So in other words, it's very immature on the ends, and you can tell this, especially after a frost, the wood will be dead. You generally want to avoid cuttings from those type of canes. In other words, choose those canes that have well-ripened wood. The wood will be firm. You have a very small amount of pith compared to the wood itself. When you cut through it, you can look at the pith there, and it will give you some idea if you have a good cutting. If you want to go so far as to make a starch test, you can do this, but I think most people can tell just by cutting into the wood how it cuts and the amount of pith in there gives you some idea if your wood is ripened, especially if it has a good color to it, if it's withstood several good frosts. If it was immature, you wouldn't have much to work with, so you could pick it out right there. Now, after you've made your cuttings, how can we get the best possible rooting out of those cuttings? What are some of the treatments that we use to improve the rooting? Okay. First one is callusing. Generally, you'll get a better take of your rootings if you will callus your cuttings before you plant them. Callusing, and I've also called this preconditioning. I'll refer to this term right along, preconditioning, meaning the cuttings after you've made them, you can store them, and if you store them in the ground, they will precondition themselves. Here's a good example right here of preconditioning. We made up cuttings to find out the best time of the year to plant these things. Well, first of all, we decided how should they be planted? How should they be stored? Do you want to store them right side up, upside down, or lay them flat? So the first experiment we ran, we stored them in these three positions in addition to refrigeration. And as far as a successful take goes, whether you get 75% or 80% or 85%, it didn't make a bit of difference. You could store them any position you wanted. Just don't let them dry out. The only catch was that the cuttings that were stored upside down took off and grew better than the ones that were stored right side up or flat. So that by the end of the year, they were a heavier rooting, just like those mallet cuttings. They were heavier. That was the only difference. As far as successful take goes, no. We don't care how you store them, upside down, sideways, or anyway. If you're going to store them, say, in the ground, make sure that they're well covered so they cannot dry out. And don't store them in a place, if you're outside where it's raining, don't store them, say, in a nice big pit you're going to dig that's going to fill up with water down there. Because if you have a wet spot, you can kiss your cuttings goodbye. They develop a horrible smell, and that's the end of them. After that, they won't grow. So in other words, storage is important. But in the ground, the cuttings will gradually callus themselves. In the early winter time, they remain dormant. By then, about January and February, they start callusing slowly as the temperature rises in the ground. In the early part of the season, up to about January or February, the temperature down below, say down at 3 feet, is warmer than it is at the 1 foot level. We put in thermocouples. At the 1 foot level, we put them in down at the 3 foot level. And for the first November, December, and January, there was a 1 degree difference in temperature between what was down below was warmer compared to the top. Then about in the February, we get a change. In other words, first the temperature is even between the two depths. And then after February, the temperature at the high level, at your 1 foot level, is, say, 1 degree higher than it is down at your 3 foot level, because it's starting to warm up now in the spring. But it is that higher temperature in the early part of the season that's where your cuttings are upside down. It starts that top bud pushing. It's more advanced than the ones that are right side up. So being more advanced, then once the bud starts growing and hormones are produced to start enrooting, it's a little more advanced when you plant them. So this is the reason why I told you that the take was the same. But the rootings were larger where they were stored upside down. All right, we stored these cuttings, and then we also, I wanted to give you a comparison of storing, say, at 2 levels. Down very deep at 36 inches and relatively shallow at 18 inches. As far as the take goes, and then also compare with refrigeration, where you put your cuttings, say, in a fruit bin with moist wood shavings over it, and let it sit there until you're ready to plant. In other words, we made one planting on February, in the middle of March, the middle of April, even into the middle of May, that late. The first work we did, where I told you we planted them right side up and upside down, we only went as far as April. Then we decided, well, what kind of a take would we get if we even extended it very late in the season? So this is why we stuck in this particular one here. All right, as far as the take goes, the early planting, March and April, are all about the same. But this was the best right in here. In other words, our middle of April planting gave us our better take. When we went into May, it was still a good take. Nothing wrong with it. But when you compared the weight of the rootings, then the difference came right in here. These were the biggest rootings in the April planting.
Is that at Oakville or is that?
This is down at Fresno.
Okay, that would definitely vary with climate though.
It would vary from one place to the other as to, in other words, your season would be later the farther north you went. If you went up to Oakville, you wouldn't plant it as early. It depends on your season. But your cuttings will precondition themselves in the ground. They'll tell you when to plant. We've always got our best take, say at Fresno, at our April planting. And it's because of where this callusing and preconditioning stage is. We found out that when you plant in March, your top bud is growing. But it's not until April you not only have the top bud growing, but you have roots coming out. So this consistently has been our best take and our preconditioning where you have both ends growing. So I always say, well, if you're going to store them in sand or soil, callus them or precondition them until both ends are growing. Refrigeration is very touchy. As a rule, I will say that the later you plant, the worse it gets. Refrigeration is very detrimental, especially if you hold them March and April. It starts then taking a nosedive.
Bud takes fall off that badly too?
This is bud take right here.
I mean,
Not only bud take, but the size of your rooting drops way off.
keep the bud for bud to fall off like that.
I don't follow you.
Store wood in refrigerator for bud wood, you have that drastic fall off.
Oh yeah. In other words, if you store also for budwood, the longer you hold this in refrigeration, there tends to be a decrease in the viability of your buds. You're taking not quite as good. But refrigeration can be very detrimental in the late part of the season. So I'd say to avoid refrigeration late in the season here, except with further work now, if you're going to hold them late, just before you plant, pull them out of refrigeration and warm them up so they can callus themselves or precondition themselves before you plant. Bob?
Do you get more roots by planting earlier, like say?
I wouldn't say more roots. You get bigger roots and a larger plant by right in here, because at this particular stage both ends are growing. At this stage here nothing's growing. Earlier nothing's growing. March you have your bud growing. I think that's about it right there.